Hi everyone, this video is on death, manner, mechanism, and cause for forensic science. Let's start by looking at case 67203. The body of a 50-year-old man is discovered in the basement of a mall. Detectives this time are going to handle finding the suspects. Your role is to estimate the time of death for this individual. So being the forensic investigator you are, you immediately make observations and collect data. What you're able to discern is that the skin of this individual is pale. The body is at about 90 degrees Fahrenheit when the ambient temperature, the temperature of the basement, is at 78 degrees Fahrenheit. The body has a reddish color on the back that disappears when touched, and the limbs are starting to appear stiff. How could you use this data to estimate the time of death for this individual? Well, I'm confident that's something you'll be able to do after watching this video. So first off, what is death? Is death when you stop breathing? Maybe it's when your heart stops beating. Well, turns out that neither of those is currently the case. Humanity has developed better and better technology for keeping someone alive. Nowadays, I can use a defibrillator to get the heart to start beating again, or ventilators to keep the lungs breathing even though the person's body naturally can't. So, since I can keep the brain alive during these system failures, whether it's the heart or the lungs, maybe it's when the brain stops. My point here is that the definition of death has changed over time and is going to continue to change as our technology gets better and better. For legal purposes today, death is defined as occurring to an individual who has sustained either irreversible stoppage or cessation of their circulatory and respiratory functions, we're no longer able to get them to start back up, or irreversible cessation of all functions of the entire brain. When a person dies, their body goes through stages. The first stage is commonly called stoppage. When stoppage occurs, the heart stops beating, so there's no more oxygen or glucose sugar to reach the cells in your body. Your bodies need those to sustain their life functions. That means there's less energy for your cells. The thing here is some cells have reserves of oxygen and glucose will keep them going for a little bit longer, but others don't. They'll immediately start dying once that supply is cut off. When this occurs, anaerobic respiration is going to take over for your cells. Normally, your cells do aerobic respiration with oxygen. In the absence of oxygen, they can kick over to anaerobic respiration with glycolysis and make a little bit of energy. The thing to keep in mind with this, though, is with aerobic respiration, I can make 36 to 40 ATP per oxygen molecule. That's a lot of energy. With anaerobic, I'm only making 2. So this isn't going to be enough energy to sustain your body's cells in the long term when oxygen's been cut off. That's why toxic waste is going to start building up, especially from anaerobic respiration when things like lactic acid start developing. pH is going to become more acidic in your cellular environment and cells will rapidly die. After stoppage comes autolysis. Autolysis literally translates to self-digestion. Auto-self, lysis-split. This is when enzymes inside the cells start to release and start digesting the components of the cell itself. You can see in this diagram a cell going from its normal circular structure to being broken down from those enzymes digesting it. So for our purposes in forensics, we want to know, well, how did the person die and what caused their death? This is decided by multiple professionals. One is the coroner. Coroners identify the body, meaning who is this person who died, notifies the families that the death has occurred, and issues a legal death certificate certifying the death. To become a coroner, you just have to be publicly elected or appointed. In many states, you need a little bit of medical training, but in some you need none at all. It's a completely political position. Another professional is who we call the medical examiner. The medical examiner is going to be performing autopsies on the body and investigating manner and cause of death. To become a medical examiner, you must be a certified medical doctor. And there are also forensic pathologists. Forensic pathologists perform autopsies, investigate the manner and cause of death, but they can also determine the presence of disease and toxins and have training specific to the fields of forensics. To become a forensic pathologist, you must be a medical doctor and receive specialized forensic training. One of the things we want to consider when dealing with a death in our investigation is what we call the manner of death, or how did the injury cause a person to die? It could be what we call a natural death. This is the failure of a body function by age or disease. For example, a heart attack or kidney failure. A death could also have the manner of being an accidental death. It is an unplanned event that's causing the death. Perhaps there was a car accident or someone sustained a heavy fall. Death could also be suicidal. It is a purposeful act of killing oneself. Or it could be homicidal. This is when the death of one person is caused intentionally by another, such as with a murder. And this tends to be what we see in forensics on CSI and other TV shows. But medical examiners and forensic analysis can be used for all other types of death as well. Some deaths are undetermined. If the manner of death is unknown, we're not able to explain if it's a natural or accidental death. It'll be listed as undetermined. Let's practice identifying manners of death. Let's look at case 1. A man with a heart condition is assaulted and dies from a heart attack during the assault. What would be the manner of death in this case? Well, it's actually homicidal. The purposeful assault is what ultimately caused the heart attack. Why did I classify it this way? Well, the assault is what we call a proximate or underlying cause of death. If I were to think of what, the assault caused the heart attack, and that heart attack was ultimately caused by years of heart disease. So our assault would be our proximate cause. The heart attack is our final cause. Let's try another case. An elderly woman dies due to neglect by her son, who lived with her. What would be the manner of death in this case? Again, homicidal. That purposeful neglect is ultimately that proximate cause or what led to the elderly woman's death. Now, this is me analyzing it using our concepts in forensics, but ultimately a court of law is going to make the final decision on what the manner is. And this is where prosecution and the defense will analyze every possible angle to see, was it really the assault or really the neglect? Another term we use to describe death in addition to manner is the mechanism. The mechanism is a specific change in the body that caused the death. For example, an anti-mask protester purposefully coughs into someone's face and infects them with COVID-19. The individual coughed on is hospitalized and dies of respiratory failure. On the death certificate, should we list the cause as the purposeful cough, as the virus, as the failure of their lungs? What should we list for the manner? Well, here's an example of one such death certificate. Here, the underlying cause was identified as COVID-19. That infection by that virus is what led to the mechanism or the specific change in the body that caused death. Here it's listed as acute progressive hypoxic respiratory failure. Lungs are failing to breathe oxygen to the rest of the body. What about the manner? Would I count this as homicidal or accidental? Again, court of law is going to determine what is the manner of death in this instance. Big thing here is mechanisms that specific biological change that caused the death. To determine when a death occurred, we would need to calculate what's known as the post-mortem interval, or the PMI for short. That's the time interval since that individual died, or when you discovered it, up to the point when they died. To use death to calculate PMI, it turns out that the body changes in predictable ways and stages after death occurs, and this happens the same way for all individuals. In science, you always want to ask yourself, well, how do we know that? To determine the stages of death, we have and currently do utilize something called a body farm. People who donate their bodies, refer to them as cadavers, their bodies are placed out into different environmental conditions, and we wait and see how the death progresses. This research lets us be able to determine when a person dies. So taking this data from body farms, we now understand the progression of the body after death. And death is also referred to as mortis. This progression goes through the following stages or phases: Pallor mortis, algor mortis, livor mortis, rigor mortis, and putrefaction or decay. Now, I don't want you to think this as A causes B, causes C, causes D, that it happens in a sequential order. A more accurate way to represent these phases would be like this. Counting the hours after death, here I have the first letter representing each of the phases. These stages overlap one another and can occur at the same time. Here you can see that Pallor happens the same time as algor. Algor is occurring when livor and rigor is occurring, and putrefaction is occurring after. So as I go through these in the order that the arrows are listed, just please keep in the back of your mind that they often overlap. Let's start with pallor mortis. Pallor means pale. Mortis, death. This occurs in the first 15 to 20 minutes after death. When this happens, the body becomes pale due to the lack of blood flow. Remember the stoppage stage of death. The body temperature will begin to decrease as well because that oxygen flow isn't occurring, isn't helping generate that heat that the body releases. This isn't very useful for determining a PMI because it really only tells you the body died about 15-20 minutes ago. And odds are, if you're an investigator, you're not finding the body that quickly. The next phase, algor mortis, algor means cool, occurs up to 24 hours after death, and because that is much more useful. During algor mortis, the body begins to cool until it hits room or ambient temperature. There's a continuous loss of body heat, and the rate of that depends on the environmental conditions. It's useful for PMI up to 24 hours because we can calculate the time it would take for a body at regular room temperature to decrease down to the ambient or room temperature in the environment that it's found. When doing these calculations, something to keep in mind is that the time of cooling varies based on how long the body's been dead. The first 12 hours, the body loses an average of 1.4 degrees Fahrenheit per hour. For the next 12 hours, the heat loss is slower. It's at about 0.7 degrees Fahrenheit per hour. Let's put this data together to estimate the time of death based on algor mortis. A body is discovered in the woods, had a body temperature of 80 degrees Fahrenheit. If the ambient temperature is 75 degrees Fahrenheit, when did this person die? And assume that the average body temperature is 98.6. So let's try this out. The first thing you want to do is subtract the average body temperature from the temperature of the body when you discover it. Doing that in this example, I'm going to take the assumed average body temperature at 98.6 degrees Fahrenheit and subtract it from the body temp that I discovered the body at, which was 80 degrees Fahrenheit. That gives me 18.6 degrees Fahrenheit. What does that mean? That means that this body has lost 18.6 degrees Fahrenheit since the individual deceased. To give me an accurate PMI, the next step I need to do is determine how long it took for this individual to lose that many degrees. And you always want to be mindful of our rule that the first 12 hours is a loss of 1.4 per hour, and the second 12 hours is a loss of 0.7. So for the first 12 hours, if I take 12 hours and multiply it by 1.47 degrees Fahrenheit, that gives me 16.8 degrees Fahrenheit that should be lost during that time. Well, we know our individual lost 18.6, so then I know this body's been dead for longer than 12 hours. To figure out the remainder, I'm going to take my total loss, which was 18.6 degrees Fahrenheit, and subtract it from the first 12 hours, a loss of 16.8. That gives me 1.8 degrees Fahrenheit. So that's the amount of degree loss that I'm left needing to account for. How many hours would it take for this body to lose it? Well, keeping in mind that the second 12 hours, we lose 0.7 Fahrenheit degrees per hour, I'm going to take that 1.8, divide it by 0.7, and that gives me 2.5 hours to lose that many degrees. So adding these together, I know this body's been dead longer than 12 hours, an additional 2.5. I can estimate that approximately 14.5 hours ago, this individual died. This is very helpful data in a forensic investigation, and we can get this from only the second phase. We can get this directly from the second phase of death. Now, the rate of algor mortis can change based on the environmental factors at play with the body. For example, surface area to volume ratios, if the individual is thin versus large. Small, thin objects have a very large surface area and small volume. That means heat can rapidly be lost through the surface area in those objects. Large objects, though, have a lot of volume, very little surface area. So there's less area for that heat to leave, so that heat dissipation can be slower. Clothing on the body can also slow down cooling. The function of our clothing is to keep us warm. It does that by trapping in our body heat. If an individual dies with significant clothing on, that's going to slow down the rate at which they lose their body temp. Also, the retention of fluid. If an individual is retaining a lot of water, that fluid is going to slow down the cooling process after they die. Wind can also accelerate cooling by propelling that heat further away from the body. And submerged bodies lose heat faster because that heat's able to go out into the water. Our next phase is a livor mortis. Livor means color. This one is noticeable 2 hours after death and permanent after 8. Livor refers to the color that forms from the pools of blood that gravity pulls down on whatever surface that body is on. As those blood cells and vessels decompose, gravity pulls the blood there and a color develops. This color is referred to as a lividity. This will be wherever pressure is applied on the body, and what's unique about it is it's very helpful for PMIs between 2 to 8 hours, because if I press the skin during that time range of 2 to 8, the color will momentarily disappear. That's huge. That lets me know a very small time frame when this individual died. If this body is older than 8 hours, the color or levity will remain after I press it. Let's try this out. If you discover a body that has levity on the chest, left arm, and back, and levity disappears when pressed, what can you conclude about the time of death and what's happened to this body? Well, I know this person died 2 to 8 hours ago because when I press, the color disappears. Since they have levity on their chest, left arm, and back, that means the body has had pressure applied to it, both in the front and in the back. This gives me a time estimate and insight into what may have occurred in regards to that person's death. Our next phase is rigor mortis. Rigor means stiff. This begins about 2 hours after death and peaks at 12 hours after death. Rigor is when the muscles become stiff, appearing to be kind of frozen in a position. Why does this happen? Well, moving your muscles, both relaxing and tightening, can require energy, but most of that energy is spent relaxing, not moving your muscles at all. So without the energy you normally get, because aerobic respiration shut down, your muscles, instead of expending energy to relax, stiffen up. This peaks at 12 hours after death and then will begin to soften. Looking at this table, the first 2 to 6 hours after death is when rigor begins. Smaller muscle groups, such as the limbs, will start to tighten, but other larger muscle groups will stay relaxed. As we get closer to 12 hours, rigor is complete. All the muscles are now stiffened. And post 12 hours, we see the slow loss of rigor. Rigor becomes uneven and the muscles return to being relaxed. This too can be affected by environmental change, just like algor mortis. The big ones that affect rigor mortis is temperature. Colder temperatures can slow down rigor, warmer temperatures can accelerate it. The amount of activity an individual's had before their death, a lot of exercise can accelerate rigor, whereas sleep will slow it down. And body mass. Obese individuals have a slower progression in rigor, whereas thin individuals accelerate rigor. Again, we're seeing that difference in that surface area to volume ratio. The last phase is putrefaction or decay. This is after all the other phases have occurred, well after 24 hours of death, and the body's beginning to be decomposed. In this phase, we go through the phases of decomposition, going from fresh to bloating, active decay, advanced decay, and ultimately dry skeletal remains. So when investigating a dead body, keeping these phases in mind, the kinds of things you want to ask when thinking about a PMI are, is the body pale? That tells me it's been dead for more than 20 minutes. Is the body cool? And how cool compared to the environment? I can use that to do algor mortis calculations. Is there any lividity? Is there color on any part of the body, and where? And if I press it, does the color disappear or stay? I can use that for a liver calculation. For rigor, are any parts of the body stiff? Which ones and how stiff? Or is the body going limp? And with putrefaction, do I see bloating? Do I see any decomposition? This body's been dead longer than 24 hours. Putting all this together, you can have some rate of decomposition rules of thumb that you can follow when calculating a PMI. If the body has some warmth to it and it's limp, it's been dead for less than 3 hours. If the body's warm and beginning to stiffen, it's probably been dead for 3 to 8 hours. If the body's cold and stiff, it's been dead for 8 to 36 hours. And if it's cold and limp, you can be confident it's been dead for more than 36 hours. To determine the actual cause of death, rather than just the time, if you're not able to discern that just by looking at the body, an autopsy can be performed to give us more insight. An autopsy is a medical examination to determine the cause and mechanism of death. A reminder, this is performed by medical examiners and forensic pathologists. There are 2 types of autopsies that occur. The first is an external autopsy. During this process, pictures and notation are taken of the positions of the body and the new clothing that's being worn. Fingerprints are taken. Identifications of different mortises are taken. Is there vigor present and where? Is there rigor present and where? And we take various biostatistics, such as weight, temperature, and height. After the external anatomy is done, the individual who's performing it will then go on to an internal autopsy. Internal autopsies begin with a Y-shaped incision through the chest, at which point organs can be accessed, weighed, and analyzed to see if there's any presence of disease. The brain similarly is removed and analyzed. Body fluids are collected and analyzed. This is the long part. It can take up to 6 hours, but the most fruitful because it gives us insight into those internal mechanisms that could have caused that individual's death. We can also use the digestive system to give us insight into when a person died and why. Examining the contents, I could see if maybe there's a toxin, a poison, or drugs in that person's digestive tract that could have led to their demise. And I can also establish potential locations and past behaviors. If I find specific fast food or unique foods, that could tell me where that individual was before they passed away. I can also determine a timeline. Here's how. If I find any undigested food, it is likely 2 to 6 hours since their last meal, since they ate that food. Going from the stomach to the small intestine, if I find any food in that small intestine, that means it's been 6 to 12 hours since that food that I find there, because that's how long that progression will take from mouth to stomach to small intestine. If I find any food in the large intestine, I know that it's been 12 hours since they ate the food, making up the stool that I discovered. We can also use eyes as a way of establishing a timeline on when an individual may have passed. Moments after death, the eyes begin to dry out. Your eyes are constantly producing moisture. Once you die, that process ceases. 2 to 3 hours after death, your eyes will begin to appear cloudy if your eyes are open when you die. If your eyes are closed when you die, it'll take upwards to 24 hours for them to begin to cloud. Helpful information, but limited because you need to discover this for a recent death. So let's return now to case 67203. I told you that the skin was pale, the body was 90 degrees Fahrenheit when the ambient temperature of the basement was 78 degrees. The body has a reddish color on its back that disappears when it's touched, and the limbs appear stiff. Could you now estimate the PMI of this individual? My hope is that you can. Thank you, and I'll see you next time.